Hello, welcome to the Dragon lesson of software testing. Let me start by sharing my screen. So here we go. So this is about software testing, and we talk about testing in terms of fantasy. My name is Kari Kakkonen, and I'm the author of the book Dragons Out. About this presentation. So this is comparing facts of information technology, software development, and software testing into the world of fantasy stories. This presentation is meant to be used in schools to support teaching testing. It's suitable for 1 or 2 lessons. This is Creative Commons licensed, so you can use it freely for non-commercial purposes. It will also be updated from time to time, and you can find it in that link below. And obviously, I always want to make this better, so please send some feedback to me using that link there. Let's all give the idea of testing to the future generations. This is the means to do it. This presentation is based on a book of Dragons Out. So the characters, the drawings, the main themes repeat there. However, this presentation doesn't require that book, but you can use it as a standalone product to help your testing teaching in schools. I'm the author of the book, Kari Kakkonen, and my illustrator is Adrienne Sell. So she is responsible for these fantastic pictures. The copyrights are in my company Dragons Out OU, and the website is dragonsout.com. There are a number of exercises, and what you need for the exercises is paper and pencils for the drawing exercises, also a camera, because it's more fun if you take a photo of a drawing that you are doing and then share it with others. You can do sharing via any means, of course. Personally, I've used the padlet.com, which works nicely in a lesson like this. And there's also a testing exercise where you need to test something. So that something, that app, that software can be anything you have in your phone, in your tablet, anywhere really, on a computer. You can also do it as a pair exercise. These exercises work as speed exercises of 5 minutes or so, but you can also extend them to as long as you like. So let's first talk about the dragons or defects, and that we start by thinking about software. Software, as we all know, is everywhere. It can be in games, it can be in online stores, it's in different devices, car steering systems is a good example. Sometimes the software is not standalone, it's actually part of a device. It usually is meant to run or control a device, like a car actually. Software can be called also a program. Even for actually a number of programs together is a software. It's all about definitions, doesn't really matter. What you call it exactly, I think the idea is just that software is code that is running and it's doing something useful for people. And so what is a defect then? So a defect is something that is not meant to be in the software, in the fantasy world, the castle. Rather, it is the dragon harassing the castle. And in fantasy world, there are always dragons harassing castles. That's how it is. And in the IT world, there are always defects in software. It is quite human to err. It is human to make mistakes. So there will be defects always. It's a fact of life. Some defects are more harmful than others, but you still need to find even a small defect. Defects are often commonly called bugs. Here I will use the official term defect continuously. Now there's a chance to do some drawing of your own. So let's think about defects. Any defect that you have encountered, write down the name of a defect, maybe some words that describe it. It could be a typo on a website that you have found. So it could be a typo, and you'd say a minor defect, doesn't really matter that much. Then you can think of an equivalent dragon. So if the defect was a dragon, what would it look like? So if the defect was bad, the dragon is probably very big, very large dragon. So make a comparison in that way, and then draw this dragon. Try to carry through this idea of how the dragon is the defect. There's no need to aim for a perfect picture. I know many of you like to draw very much, but this is not the arts class. This is a computer class. And once you're done, share a picture to the others as agreed. So for example, using that Padlet. So there you go, draw. And now, after the exercise, you have probably shown some excellent pictures to your friends, to your fellow students in the class. Let's move on. Next topic is what is testing? What is software development? These two matters, of course, tie together. So let's discuss them together. So first piece here is what is software development? It is basically requiring something, then coding it, and then testing. These three parts. So you decide what you want to have when you code it as a software, and when you test to make it a good, as fault-free software as possible. In comparison of a fantasy story that we carry through here, it would be building the walls around a city or village or castle, and at the same time vanquishing or even killing the dragons that maybe trouble this village. So it is anything that you need to do to create the software. That is software development in short. So what is testing? That is one part of software development, as we just learned. So it is finding the defects so that they can be fixed. So we need to look for the defects in the same way in fantasy story. The children here are on the wall watching for dragons, trying to see them before they arrive to the village. When you test, you often don't find anything. That's even a nice thing, but sometimes you find defects, and then you find defects, somebody needs to then get rid of those defects. Actually, to be precise, by testing, you don't find the defect because defect is in the code. You find a failure of the software. So software does something strange, and that is caused by the defect in the code. And the test is to really try to use the software in different ways. Values, different orders, anything, any type of usage is actually testing. Again, we go for an exercise. This is also a drawing exercise. Here we design our software, meaning we draw our castles. So think of some software that you have used. Try to pick a software that seems quite tolerable against defects. So write down some characteristics of this good software. And then think of a castle that in the same way would actually withstand an attack of a dragon. Well, that would be a very good, strong castle. What kind of castle would it be? Is it small or large? Does it have walls? Does it have weapons? And then draw a castle. Again, the main thing is to carry through the idea, how the castle represents the software. You don't need to aim for a perfect picture. And again, in the end, share what you draw to others. It's more fun together. So draw. And now, after the exercise, you probably drew some amazing castles, I'm quite certain. Great, good for you. Let's move on. This bit is about test techniques. So it's easy to say that you use a software and that's testing in a way, but most likely you'll only cover number of possible ways of using the software if you just use it. So it's better if you think in terms of test techniques, and there are a number of them that help you to be better in testing, to be very simple. In a simple way, you can say that you can try to use the software correctly and in the wrong way. And you can just explore and see how it works. You can also observe somebody else doing the testing and then make other observations, other findings. You can also use multiple techniques, test techniques at the same time, which makes it easier to do the testing. In comparison to the fantasy story, a knight can draw a map and ask people where we have seen a dragon at the same time. So using the two means, it's then quicker and faster to find defects, find the dragon. So you can test actually in multiple ways. So let's try. What is testing? Now you can test something. So we do it by choosing whatever software you like. It could be a game, it could be some app in your phone or tablet or computer, anything you have available. You can do it as a pair, as mentioned earlier. And try to think of different perspectives. Maybe you want to try to find something strange, or maybe you want to understand if the software or app is slow or fast. Give it a try. Think about these angles, and then keep these angles in your mind and go through the software, the app. Use it and make observations. If you are thinking about slowness, is it slow? Is it fast? Make notes and discuss in the end. A good time for this exercise is about 30 minutes, but you can do just a little bit of it, or as you can guess, you could test any amount of time. There's never enough of testing. So test. And now, after the exercise, welcome back. Let's move on. I hope you had fun testing. Testing is lots of fun. So next bit is knights. So we talk about knights, coders and testers. So the question is, who tests the software most? Usually, both the coder and the tester have a role to play. Coder codes the software and while doing it, also tests the software quite much. Testers are there also, and they are specialized in testing, which makes them better at finding problems. It is always easier to do something when you are very good at that particular skill. Together with coders and with testers, or with developers and testers, they form software development teams. So in comparison to the story, there can be many knights together and defending a castle, protecting it, trying to find dragons, trying to get rid of dragons. The larger software you have, the more likely it is that you have a big team of developers and testers working together, whereas a small software could have just one developer. So how it practically works is, and here you can see a bit of a story example, but I'll just dive into the explanation. So how it works in practice in IT world is that developers and testers are working together in a team. They have a number of functionalities they want to create. Testers always try to test with whatever bit is ready for testing, find defects, and then they hand it to, typically they hand it to the coder, to the developer, who will then fix it, if possible, immediately. And this goes on and on throughout the software development project. Sometimes a coder finds the defect, of course, and then fixes it immediately. Sometimes the roles are so mixed that anybody who is a tester can also fix a problem. It's really up to how software development teams have collective skills, so maybe all are quite multi-skilled. It depends. So you might need lots of people, like the picture here mentions many other people. So let's talk about that a bit more. There are other testers, not only coders and professional testers. There are users. So anyone can actually test a software, even for the coders and testers test the most. So the users usually take part of the latest, last stages of a software. They can be present all the time when the development is happening, of course. But their view is the view of a user, of the user interface as well. This kind of testing is often called acceptance testing. So they try to think in terms of, can they accept how the software works? And they will find defects as well. So in comparison to this story, to a fantasy story, villagers help knights to find dragons. They are not going to kill the dragons most likely, but they can find them, and then the knights can get rid of the dragons. So a tester really can be anybody who has testing skills and tests. So it's more of a role in the end than a person, even though there are those who are full-time testers. Then there's maintenance team. So when a software is given to the users, put into the production, usually a group of people starts to maintain it. So they monitor how the software is used and runs, and they fix it if needed. In other words, they maintain it. So they test and fix defects. They can also help users. That's a typical part of their role. And so maintenance team or operations teams, team as it's also called, often manages on their own. They like to manage on their own, but they can ask help from developers if needed, if there's a particularly difficult defect. Just like in a fantasy story, a hunter can ask knights to help to kill the dragon. And then if you go further, sometimes the hunter, the maintenance person, the operations person is brought into the development team to help the development team all the time. And that would be called a DevOps team. There's a next slide of that also. So DevOps, also sometimes mentioned as continuous delivery, means that the operations knowledge or person is within the development team. So the team actually runs, develops the software, runs the software, supports the users all at the same time. So in a fantasy story comparison, the hunters and the knights band together. They form a team that together can effectively find dragons and destroy them. So this is DevOps, development and operations together, delivering continuously new features to the users. And then we have product owners. So somebody must pay the bill. Somebody must order the software. Somebody must tell what the software should do. So this is a business perspective. It's commonly called product owner. And these product owners order the software from the development teams. They can be roles within a large company. Sometimes you can also just say, the company, a business person, the management person of the company orders a software. And so what the product owners of the business people do, they explain to technical people, to the development team, what the software should do. And they do it together. So they make the solution, the software better by talking about it. In the same way as in a fantasy story, lords and ladies would order castles from knights and plan with them what kind of castle it should be to be a safe castle from, safe from dragon attacks. So business or product owner, very important role. And also, so they test. They test if things go as they wanted. And then you have expert. experts. So experts help in areas where the development team doesn't have all the knowledge. Typically, these areas are some very narrow expertise topics like usability, how easy it is to use a software, security, can some bad person hack into the system, break into the system or not, and performance, is it fast to use the software? So experts help development teams. In the comparison to a fantasy world story, experts would be sages, wise men, wizards, who are supporting villagers and knights in a battle against dragons. So that would be a sage, an expert. Next, another exercise. Again, we get to draw. This time we are drawing testers. So that could be a knight. So think about what kind of a tester would be a good tester. Does it mean that the person should be curious, handsome, fast, patient? Write down what you think makes up a good tester. And then think about a knight or other type of person or character that can find dragons. So what kind of characteristics would this knight, for example, have? Would it be a person with a great harness, very effective defense against dragons? Maybe there needs to be a weapon that can be used, a sword, a bow. How would that knight look like? And then draw a knight. And again, no aim for a perfect picture, rather try to carry through your idea about how the knight can represent a tester. And again, share with others in the end. That's more fun together. So now, draw. And welcome back from drawing. So I'm sure you drew some really cool testers. It would be great to see what you drew as well. By the way, there are advice on my website how you can send some pictures to me, and I can upload maybe a few of them on the website for others to admire what you have done. Anyway, let's move on. So we've discussed that there is software and there are defects, castles harassed by dragons. But there are different kinds of defects. It's not only the typo or something doesn't work correctly type of defects. There are many kinds of defects. You also can't find all the defects, that's a fact, but still you should try to find all these defects. So some defects are big, some are small. Some are easy to find, some are hard to find. Some are hard to remove, some are easy to remove. All kinds of defects are there in the same way as in fantasy stories there are all kinds of dragons. The fact that you need to remember is that if you find a bad defect, then that must be fixed quickly. Other defects, you can make up your mind what to do with them, but the severe defects, do something about it before somebody loses money or gets killed. Things can happen when software doesn't work correctly. So let's take a look at the different types of defects. Here is a dragon that represents one defect. Let me first explain what the dragon does. So this one is a red dragon, medium-sized, quite difficult to find, but once you find it, quite easy to get rid of. It doesn't fly even though it has small wings, and it breathes fire. It likes to eat lambs. This is the annoying dragon. And this dragon represents memory leak, which is a type of defect that is very annoying. Things look all right, except that after a certain time, the whole computer maybe crashes. And usually this thing happens because the computer program, the software, is using memory. And the memory is not released after usage. It should be released. And obviously this can create problems. So the computer runs out of memory, and when that happens, it just stops. So how you find it is by trying the software bit by bit, line by line, code is in lines, and then you find the line that has a problem, you fix it. It's quite technical, so it's actually something a developer would do as part of that testing. Anyway, a great example. Then we have robin dragons, so dragons that steal things, harass castles, steal food, steal treasure. They can fly, they can be big or small. So these come in many varieties, and they represent quite nicely functionality defects. So there are many functionalities. The software you have out there, they do really many kinds of things. And then you find problems, defects in these functionalities. They can be of any kind, small, big. Something goes wrong in a bad way, something goes wrong, but people don't really care. So you have all of the different severities of these defects. So obviously, lots of the defects are like this. Maybe most of the defects are actually functionality related defects, and then you need to fix severe ones, as discussed earlier. Then what we can have is mean dragons that are black and steal food without being detected. That seems to be part of the thing. They have very hot fire that they breathe. Now these represent security defects, like the black hats, the hackers, the bad people who break into systems and try to steal some data, some information on systems, maybe benefit from it by selling it to somebody. These defects need to be found as well, and again, removed. Then we have fast dragons. So these dragons are purple, very difficult to find and difficult to get rid of. They like to steal gold in secrecy. So this comparison leads us into performance defects. So defects that relate to how fast this software is, how fast it is for the users to do something, even when there are many users in the software. And if something works, but it is slow, that's a performance defect. In the worst case, it is so slow that users don't like it and they leave. They go somewhere else. And of course, this can't happen. So even though a software works, but is slow, you can do something about it. You can make it faster. You can fine tune it. You can optimize it. There are different ways to do it. So it's not an obvious defect, but it's a problem, and it can be found in the same way, similarly as other testing defects. Then there are showy, troublesome dragons. Big green ones, easy to spot, but quite difficult to get rid of. They stalk gold, they protect their territory, which is a problem for people. So what these kind of big dragons represent is usability defects. So usability defects are something that makes software hard to use. So a good usability is something that is easy to learn, easy to use, and something that people like. And the bad usability is the opposite. So when testing for usability, you try to find these problems. Something is hard to learn, something is hard to use. And then once you find them, you can try to change the software in a way that it is easier for the users. So that's why it's quite difficult. There are many opinions. And then there are underground dragons. Dragons that are not flying, but going through tunnels, going in underground in earth, trying to find their way into cellars of castles, finding easy food from there. These dragons represent hardware defects. So even for a tester would think first that something is wrong with the software, if you investigate more, sometimes the problem is not the software, but the hardware under it. So the dragon, the computer that the software runs on, or the network, any devices that the software is running on. And so this equipment can break, and then you can replace it with the correct one and then the software runs again. Still, it takes time to identify which component of the big system is faulty. Then there can be shadow dragons. So what are they exactly? They look like dragons. They are grayish. Confuse people. They confuse people a lot. So they represent testability defects. So sometimes a tester thinks that there is a defect. It looks like a defect, but under further analysis, it turns out that the defect is actually caused by tester doing something wrong. So it's actually related to testing itself. Maybe the tester used the wrong environment for testing. Maybe the tester had the wrong data, or maybe they just interpreted something wrong. So sometimes what looks like a defect is not a defect, and that is usually classified as a testability defect. So you look into it, but then you in the end conclude we don't need to change anything. Then there are nice dragons. So not all dragons are bad, like bad defects you need to remove. There are also good defects. So nice dragons are green as well, easy to see, easy to find. If you want to get rid of them, it's easy. You just say go away. And they like to help people as well sometimes. So what are these nice dragons? Are there defects that are actually good? Well, yes, if a defect helps you understand how the system behaves or how good testing is, then that sort of defect is good. So we talk about defect seeding or mutation testing. So here, coder or tester creates a defect into the code of the software on purpose. And then the theory is that once you test after that, once you have found all those seeded defects, you have found all the real defects as well. So it's a way to measure your coverage, measure how well you tested. And in that way, it helps testing and finding real defects. So these are the nice dragons. And then we have stubborn dragons. So they are like any functional defect usually, green, harassing people, but they do it again and again, repeatedly. And why they do it repeatedly? Good question. Why a repeated defect happens, that is because version management fails. So we talk about version management defects. So any defect that was found earlier and was fixed strangely comes back. So in a later version of software, if a defect that we thought was gone, it goes back there. And why? Good question. Somebody used the wrong version. Somebody took an old version and inserted it into a new piece of software, and accidentally the problem that was fixed in another version of that component comes back. And this is fixed by deciding about good version management practices, and sometimes a tool to manage all that source code. So stubborn dragons. Then we have confused dragons as well. Quite small, harassing large dragons, easy to find, easy to get rid of. They fly around. The confused dragons represent documentation defects. And that means that the documentation, for example, a user manual, says that the software does something, works in a certain way. But how software works is not like that. It works in a different way. So there's a difference for whatever reason. And this is a problem for users, of course. So how this kind of documentation defect is fixed is by aligning the documentation and the software together. So either you change the documentation or you change the code so that they work in the same way. And then it's fixed. So it's all about documentation. And we go to our final exercise. Now, if you are in a hurry, this is another dragon drawing exercise. So you can actually even skip it, or the point here is to think about the good dragons. So if you have still some more time, do it. Think about a good defect, something that has helped you understand how this software works. And then again, transfer that into a dragon. Think about what kind of dragon would be a good dragon. How could it help people? Again, the size equals the size of the defect and so on. So it could be any kind of dragon. And again, draw a dragon, try to transfer this idea of how this good dragon, these good characteristics somehow transfer into a dragon. No aiming for a perfect picture. Otherwise, the time is not enough. And again, share with others. It's good fun. If it's hard to think about a good dragon, just think about any dragon. Just pick another defect when you picked earlier for drawing your first dragon. So draw. And now, thank you. Welcome back. It's great that you draw another dragon, and I hope you enjoyed sharing it with others as well. Let's go to the last slide, which is a special thank you for you in taking interest in learning software testing and going through this presentation. I hope you learned something, and that will help you be a better tester, better user, better coder or developer. Some basic skills for you. And if you get more interested in the book, it can be ordered from there. The book project can be also followed at thedragonsart.com. There are also resources there to get more links into testing websites and testing books. So if you got into the testing mood, the world out there is full of testing knowledge. Just try to find it. It's there. My website helps a little bit. Thank you and enjoy testing. Bye.